Okay, so now we have a new problem. And we don't know, without a calculator, how do we do something like this? Because we don't know what the inverse sine of minus 8 over 17 is, right? Who's next? Iman. Oh, you got a good one. You with me? Okay, you ready? So, okay, no problem. That's all I asked. That's really all I need, is just trying. Okay, so, does anybody remember what I said? Like, if you don't know what to do, what do you do? Did I tell you that rule yet? If you don't know what to do, do this. Have I told you that rule yet? Anybody? Did anybody remember me saying that rule? Draw a triangle. Thanks, Laura. Draw a triangle. If you don't know what to do, draw a triangle. Sometimes that works. Most of the time, that'll give you what you need. Okay, so let's draw a triangle. So here's my angle. And basically, I'm saying here that the sine of theta is equal to minus 8 over 17. Aren't I? Good. So what does that mean? How can I put these on my triangle? Can I put these on my triangle? Okay, so how would I do it? Opposite is minus 8, good. And the hypotenuse is 17, right? All right, so does anybody know, I think was this an 8, 15, 17 triangle, or is that right? Does anybody know offhand, or do we have to figure it out? 15? Okay, thank you. So this is 15. Okay? So now, remember, I know that this is in, what quadrant would this return an angle in? Back to Iman. So what angle, what would theta be? Just between. I don't want you to give me the actual angle. I just want to know what it would be between. Nope. No, where is inverse sine defined? Does anybody know? It's between minus pi over 2. This is, I mean, I don't know how many times I have to say it to tell you that this is super important. 1 and 4. Nope, not 1 and 2, 1 and 4. Yeah. But it's not just 1 and 4, it's between minus pi over 2 and pi over 2. It is in 1 and 4, but between minus pi. Thank you. And then cosine is between 0 and pi, or 1 and 2. Okay, so that means this answer has got to be in quadrant what? Four. Well, it was Iman, but okay, yeah, quadrant 4. Right. So now, in quadrant 4, the tangent is what? What's the tangent of theta? Or the tangent of this triangle? Iman? What's the tangent of this triangle that I just drew? Good. That's it. We're done. That's the answer. Notice I didn't even have to find my angle. I just kind of worked through my angle, didn't I? I don't know what the angle is still. I mean, I can find it out, but I don't care. Does everybody get what I just did? We'll do more. Don't worry. Is there any questions about this? Everybody's good? Okay. Okay, I don't know what's next, Zachary, but you're in. Oh, we're not going to, well, okay. We're not going to do this one because we need a calculator. But we don't need a calculator for A. You want to do it, Zachary? Is it Zach or Zachary? Which do you prefer? Okay. I'll call you Zach then. I prefer short. Okay. So, what can I say about this? Do you need any help, or you want to do it on your own? Yeah, exactly. Well, not exactly. So this is the same as 1 over the, here, let me see if I can write this. So 1 over the inverse cosine of theta is equal, no, let me write it better. What I'm really saying is that 1 over the cosine of theta is equal to 2 over the square root of 3. Isn't that what I'm really saying? Yes. So I can flip this. I can say cosine theta is equal to the square root of 3 over 2. So theta is equal to pi over 6. Yay! Thanks, Zach. Perfect. Pi over 6. Okay? Let's see what's next. Okay, so now we're going to do, this is, we actually, that's 6.5, yeah. I think this is now 6.6. So I want to find the inverse function of a trigonometric function. So I have, and we're just going to do like we did when we found inverses of regular functions. So I start with f of x is equal to 3 cosine x. By the way, is there anything wrong about this? Is there anything that is, can you see, does anybody recognize anything in this slide? Yes, thanks, Anka. What should it be? Exactly. I kind of was going to change it at one point, but I was like, yeah, this is good. I'll leave it. Okay, so remember, cosine has to be between 0 and pi, or inverse cosine. So we're going to change the domain, which will change the range of the inverse. Okay, so we have, so remember the steps for finding inverses? We changed the y to an x. I'm sorry, I write what I say instead of what I mean. We change the f of x to a y. We exchange x and y. And then we solve for y, right? That's the same process as we always do with inverses. So how, let's see, who's up on top again? Anka, that's perfect. Let's do it together. How do I solve for y here? Well, how would I start if I had, it's doing it again. How would I do it if it said x equals 3y squared plus 1. Then what would I do? Yeah, subtract 1 from both sides. Same. Exactly. Then divide by 3. Perfect. So I have x minus 1 over 3 is equal to the cosine of y. And now here's where the inverse happens. Yes, kind of. There's a y, it's cosine y instead of x, but yes, perfect. So this part maybe you don't know how to do. Do you have any ideas? If not, I'll show you how to get that, because we want to get the cosine away from the y, right? Because we want to solve for y. Take the inverse. I take the inverse of both sides, exactly. The inverse cancels out the function. So I end up with y equals, I'll just rewrite it this way, inverse cosine of x minus 1 over 3. Right? And that's it. There's the answer. Now, first I said, okay, so find, good job, good job. Now it says find the range of f. So what's the range? Okay, so let's see. So here's my function. You want to keep going on, or are you exhausted? Okay, so let's do, we know the domain is between 0 and pi, right? We already said that. What's the range of the original function? Well, yeah, but that's probably harder to find. I guess, is that harder to find? I'm not sure which way is easier for you. I mean, for me it would be easier to do it from the original function, but if it's easier for you to do it from the other function, that's fine as well. I can see how you could do it from either one. Did I scare you? Okay, no problem. So let's do it both ways. So I can show you how both ways work. So think about the original function. What's cosine? What's the range of cosine by itself? Nothing around it. Exactly. So now, if I multiply that by 3, what's the new range? Because really that changes my amplitude, right? Exactly. Think about it on a graph. And then I'm going to shift it up 1, right? So what's my new range then? Exactly. So my range is going to be, actually including, from -2 to 4. Now you can also do it here because the inverse cosine has to be on a, so the cosine can only be from -1 to 1, which would make that -2 would make that -2 minus 1 is -3 over 3 is -1. And 4 would make it 4 minus 1 over 3, which is +1. So either way you could do it. And in reality, what we're going to do is we're going to say, this is of f of x. And then I'll give you the easy part, Anka. What's the domain of the inverse? Exactly. So it's -2 to 4. And the range of the inverse is 0 to pi. Perfect. Okay, good job, Anka. Excellent. Is everybody good here? Any questions? Okay, solve this equation. Arian, you're up. You with me? That's okay. Hold on a second. Okay. Okay, I'm ready. So here we go. Well, what's the first thing you would do? We want to solve, right? So what if I had, let's see, I want to basically say what is x, right? So I have to start moving stuff away from it. What's the easiest thing I can move away from it? The 2, exactly. So I do what? How do I move it? Divide by 2. Exactly. So I divide both sides by 2. I get the inverse cosine of x is equal to pi over 4. Right? Good. So now, what can I do next? Any ideas? I want to get the cosine, inverse cosine away from the x, don't I? So I just want x by itself. So what can I do? Yes, perfect. I take the cosine of both sides. And I end up with x equals cosine of pi over 4. And that's it. And what's x equal? What's the cosine of pi over 4? Perfect. Okay, so you got it. Easy, right? All right. Is everybody with me? Any questions? Henske and Jackson, I'm going to kill you for leaving. You got to get back here. This is important. If you can hear my voice, come back. All right. We already did this problem. This looks scary, huh? Okay, so I'm going to throw this out there. Anybody who wants to do this problem, raise your hand. I won't just make the next person do it. Everybody's kind of taking a turn. Anybody want to try this one? Raise your hand. Remember, the person who tries it usually learns the most. All right, Lauren, good job. Okay. Any ideas? If you don't, it's okay. I know, Damien. I get it. No, I have two people who keep putting the away button on. Hensky, you back? Don't go away. You already came late. Stay with me. No, I'm not going to simplify the denominator. So, let's see. What is it that we're going to do when we don't know what to do? What's the first thing we can try? Draw a triangle. Perfect. Let's draw a triangle. And we'll call this theta, right? And the cosine of theta, basically the inside part, says that theta is equal, the cosine of theta, because I can take the cosine of both sides, right, is equal to x over the square root of x squared plus 16. Isn't that true? Okay, so how do I put anything on this triangle? What can I put on this triangle? Thanks for getting your computer fixed. Is it easier to follow on a big screen than the phone? Yeah, that's what I figured. Okay, so how do I, adjacent is x, good, and perfect. This is the hypotenuse. So, can I fill in anything? Yeah, Griffin. I'm not going to simplify it. I can say that, let's call this y. I can say x squared plus y squared is equal to the square root of x squared plus 16 squared, right? So that makes y equal what? Yeah, 4. Yeah, that's all. No problem. So now we have, here, let me circle our triangle. It looks kind of like it got lost here. Here's our triangle, right? So what's the tangent of this triangle? Lauren? Exactly. So it looks way more complicated than that it is, doesn't it? Not too bad, right? You have some of these in your homework. Thanks, Lauren. Good job. Good job. All right. We did this one. Summary of inverse function properties. We pretty much did all this, so yes. Who's that? Yeah, Lauren.
That was me.
Oh, that's Griffin. Yeah.
So since that was tangent, it could be like negative pi over 2 to pi over 2. So could that have been a negative 4? Because that would equal 16 too. Like, why did you determine that that was a positive 4?
Okay, so we know that the cosine The inverse cosine is in quadrant. First of all, it says assume x is greater than 0. So
okay, never mind then.
Excuse me?
Well, okay, never mind. Keep going.
Yeah,
Sorry.
so it could only be in quadrant 1 or 2 because of the cosine, right? It's between 0 and pi. Right?
Okay.
But because x is positive, it has to be in quadrant 1.
Okay.
So since it's in quadrant 1, the y has to be positive as well. Even in 1 or 2, the sign has to be positive. But even if it was negative x, assume x is negative, it would still be, then it would be in quadrant 2. But, yeah, I get it. Then it would be in quadrant 2. So the tangent would be negative. Yeah. So, yeah. No, but even still, if it was in quadrant 2, the 4 would still be positive. The x would just be negative. Right?
Yeah. I mean, I kind of thought that tangent just dealt with quadrant 1 or quadrant 4, though. Because it was like, it's in between negative pi over 2.
Yes, that's true, only if we're looking at the inverse tangent. Not the tangent. The tangent can be anywhere. It's just the inverse function.
We're looking at the inverse cosine.
Right.
Okay, that makes a difference.
Okay, got it? Good question. Thanks for asking. That was a really good question.
Thank you.